Alrighty. So look, I'm going to probably maybe pivot a little bit here. I want to talk to you about my story in IoT and I guess how this weaves in with Azure. After all, this is an Azure event. So look, first rule for my session, keep it interactive. Make me pivot, dance, ask questions. You know, it's it's probably good if we can make this as interactive as possible. So look, IoT, it means so many things to different people. It doesn't mean a project with a Raspberry Pi. Doesn't mean an Arduino. Is it a PLC? And sorry, just adjusting my screen here. Is it SCADA? Is it something else? Is it a wireless module? James was just talking to me earlier before about Philips Hue. That's kind of IoT, right? And I don't think anyone's wrong here. So I'm going to talk to you about my journey. I hope we're friends thereafter. Sorry, I'm just adjusting teams here. So look, for me, I've always been interested in this space, and I've been tinkering for probably almost about 25 years, coupled with, I've had a stint in a really large food manufacturer, the third largest food manufacturer in the world, for about a year. Kind of drove my head in a little bit. A lot of that stuff runs on DB2 and mainframes, but a lot of lessons learned there. As well as 7 years in the last 7 years or so, working in the world of cloud, predominantly, on the for a different cloud vendor. But look, in case we haven't met, my name is Shane. My experience spans, Australian tech unicorns from some of the largest born in the clouds. I've spent some time working with Netflix, PlayStation Network, through to last year's census. So look, our time is limited. So let me just quickly introduce myself a little bit more and hopefully get a bit of a, I guess, more perspective of where I've come from and why I've built what I've built. Just bear with me. Okay, so look, I was a bit younger here, and I think the biggest risk in life is not taking one at all. So when I was 17, I decided, hey, end of year 12, with a friend, this internet thing, it was late 90s. It started, catching on. Let's build a company. So, accepted into university. I started a web hosting company with a friend on a whim. Rural Victoria in Gippsland. This internet thing was catching on. Took all my KFC money, bought a few servers, which were basically, white boxes, shipped them over to a colo in America, and we started this web hosting business. Didn't think much would happen. There's 3 pictures sliced all in together here. So the very, in the very left are kind of like the initial boxes that we had. But, that was like Windows NT4, IS4, all the way through to 2008 R2 on the very far right. So I don't know if anyone's in web hosting here, but in, 1999, there was no Plesk, there was no cPanel. This was, ADSI, VB, write your own for customers. So 8 years of my life. No weekends. My whole life revolved around the US time zone. We grew to about 15,000 customers, thinking we'd get Australian customers, but 95% were overseas. A lot of secondhand gear. We ended up buying, and if anyone's familiar with rackable systems, they are 42 RU half depth back to back. So you fit 84 servers in a 42 RU enclosure, DC powered, not AC. Plenty of learnings and a lot of time spent in the US. Fortunate to sell that business. I spent 8 years at Seek, so I moved to a scale up. This was 2006. So from like 15,000 customers to 1 customer, ultimately the same thing, right? Supporting a website. A lot of N-tier architecture, great place to work. I don't know if anyone's seen pictures of Seek's new pad on LinkedIn. Looks really amazing. Amazing culture. Definitely want to go have a tour of their new building in Cremorne. But from Blades, all flash arrays, BizTalk, acting as a bridge between SAP and everything else in between. So I said I spent some time at another cloud vendor. So I spent the last 6 years in a bit of a roller coaster, not only from a technical point of view, but I guess business acumen. No more PowerShell. No more C#, try to get a Lambda function in C# demos. It's hard to do, right? So you're forced into the world of Python and Node and everything else. From keynoting live audiences Sydney Summit through to reInvent, started the podcast, grew quite large, panels with Adam Spencer, Inner Sanctum with Sony in the PS5 launch. It was a pretty amazing sort of ride. But I'm here now at Microsoft, and I've got a slide up here from Corey Quinn. So if you don't know who Corey Quinn is, that's fine. Perhaps a little bit of homework for you. But this talks about a failure in an AWS region. So it wasn't US East 1 the other day, but just remember, everything fails all the time. Even in AWS, right? Things fail all the time. But that's not why I put it here. It's because this organization was able to evacuate a region, in under 10 minutes. So is there any takers in the chat here who this organization was? All right, we're a quiet bunch tonight, but look, it's Netflix, okay? And whilst Azure may not, have companies like Netflix, there's no reason why all of us here today can't use the Lego pieces, the blocks that are available to create such architectures on platform. They're all available, right? So before I kick this talk off, I challenge you all here to, think differently. How can we build architectures that help our customers or your organization, climb that cloud maturity curve? Because today, outages, they're no longer acceptable. Software stacks need to gracefully deal with failure. Alrighty, so some swag. Look, if anyone here, would like a $50 boarding pass, reach out. Send a message, pop it in the chat. I'll take a look later, and we will sort these out. So $50 Azure credit to do with, what you'd like to do. Cool. All right. So IoT. Now, I want to frame this session with my house isn't a science experiment. This was much earlier on. Kids are considerably grown up now, but if I want to play, I've got a shed, I've got a study, and I think just like customers having a bad experience and are reluctant to adopt, these are my customers. So the theme of this talk, before I get into the Azure side of things, is I favor reliability over any other metric. And that, if we think about, speed, cost, etc., reliability can have its drawbacks, right? It increases complexity sometimes, and it can cost a lot more. But I favor reliability first and foremost over toys. So let me quickly start sort of by level setting the type of automation that my house does. Give you a few seconds to read this, but look, I've got a plethora of disparate systems. I've got 3 systems that can read the I/O, the sensor inputs from all other systems. Haas spoke about this before. He was talking about some of these fancy protocols. I'm a big backer of MQTT. I love SDKs and things like that. Everything's got its pros and cons, but I've got around 200 bits of I/O. And when I mean I/O, like a humidity sensor would be one input. And probably more than 200 bits of I/O by the time you tally up all the relays, all the sensors, and so on. But think about the devices that you may have in your house. I bet not many of them play nicely together. James was talking to me about Philips Hue earlier. How does that play with a Honeywell humidity sensor that's, expecting a 5-volt input and it's returning back a voltage based on the relative humidity? So the point is, not many of these devices work together. You need to be able to code, right? That's the secret sauce in my house. It's my code. Now, I want to get a bit of a disclaimer done early in this talk. Whilst you may want to follow me, perhaps, go for it. But when you're playing in the realms of mains voltage, seek a licensed electrician. So don't do as I do here in all cases. There's a lot of things in my house where I've had to manipulate mains voltage. So do your thinking up front. And I think, of course, you can't plan for everything in life, but if you can just do a little bit of thinking up front, it's going to pay you back handsomely. Now, I say this, more so through the lens of double stories to which I live in. Nothing's impossible. You can always put a hole in plaster, etc. And I still do things that people think I'm crazy. Remember, I'm about reliability, and wireless offerings, they are kind of like, I don't want to say I'll look down upon them, but if I could run a cable 30 meters versus using Wi-Fi, I know the path I'll choose, right? So my back wishes maybe I'll choose otherwise, but I'm all about, reliability. So I want to start with a few pictures for this session. Now, this is when I was building my house. And I'll say, if you need help, don't be afraid to ask. There's so many people out there who will be willing to give you help. You may need to pay for it, but do your thinking up front. So, on a few occasions, I've used design services. Cable is cheap. As I mentioned, double stories, they're a bit of a hassle. They're not impossible. So over cable, even if you don't use it. So in my house, every double power point has at least 2 Cat6 cables. Every room has a motion sensor. There's a loop of RS485, there's loops of 1 wire, and I run spare cords. So I had a bit of a plan. So in some senses, I've probably overcabled in terms of Cat6, but I use it as a transport medium for other sensors in my house. So, I've got a telco rack. I've got a 42 RU HP rack. There's about 10 new in use today. There was a heap of cables. I've probably ran, to be honest, another 50 more. So there's about 200 cables terminating in a telco rack. So 8 RU of patch panel, using things like catenary wires, cable stays, and so on. So, big umbilical cord here. So the house is starting to take place. But there are always things you're going to miss. I've started running loops of Dallas DS1820B temperature sensors. So if you pull apart any temperature, like your thermostat, a Nest, etc., they'll have a little Dallas IC integrated in there. How are you going to address this later? Wireless systems have come a long way, but think about a wireless device that may turn a light off and on. You've got a TCP/IP stack. It's going to communicate through to an access point, a switch, back up the stack, which is making a call. A single cable can eliminate all of this. So here's a bit of a SketchUp of my house. It looks not too dissimilar to this render. There's a lot going on here, a lot of planning that's happening everywhere that I've built. So my front yard. There are 3 main systems here. We've got irrigation. So of course I want control over this. And we've got lights. So every light in every step is controllable. Every pear tree running along the sides of this image here is also uniquely controllable. So if you think about that in a electrical point of view, they're an individual circuit, right? So you've got a lot of relays going on. And then we've got sensors. How do I know when there's presence in my yard? So I use industrial laser sensors that are retro-reflective, that are embedded in the walls. And when it gets dark at night, there's ultimately a beam. Beam gets broken and acts as an I/O input. So if my neighbors didn't think I was a little bit peculiar, this probably sealed the deal. Here is a picture of my letterbox when I was building it, right? So, what do you have in your letterbox? Well, this is what I have, right? So it's all about reliability. Even irrigation, you can see here, is clad in hard conduit. So all cables, everything, nothing's buried, everything is going through conduit. So all of this terminates inside my letterbox. Now this was taken ages ago. I'm not sure if the audio is coming through,
just
but
got
if I can zoom through.
Sign mounted.
I'm gonna just click through a little bit.
Hey.
Nokia Lumia, back in the days, Windows Phone.
Back to our trusty laptop.
So obviously today, all of this is automated. It's all through, sensors triggering this and that.
Laptop here has all my relay output ports. It is currently K8, so we're going to press that and bingo.
So these lights today have been replaced with, WS, forget what they are, but every LED is 65K colors, uniquely control them, do something pretty for Christmas, etc. Through to things like building one's irrigation. So it's gonna click through API controllable. So there's an API wrapped around my irrigation system.
A HTTP interface of Open Sprinkler. So right now, when I hit these stations, water should just start spurting out of valves. I don't know if you can see in the distance over there.
So today I still use this system, but I could have easily built this myself. But yeah, I guess the point here, irrigation, everything has some form of API wrapped around this. Through to, as I mentioned before, in the front yard, it's nighttime. I illuminate the bottom step only. The beam is broken. Then, it acts as an input and things just kick off, step after step after step, lights up. And that theme, kind of continues throughout my house. If you remember what I said earlier, I said the theme for my house is reliability. So, put your Pis away. Pis are incredibly popular. If you're building for reliability, use a microcontroller, use a PLC. Has mentioned Azure IoT Sphere. Anything that reliable is probably not going to be running on a Pi. It doesn't mean they're useless or anything like that, right? A lot of people dabble with Pis, but a Raspberry Pi, it's a single board computer, an SBC. It needs to be updated. It needs to be watered and fed. We talk about, cattle, not pets, when we're moving into the cloud. Pi is probably one of those things that, it is a bit of a pet here. Have you ever had a corrupt file system, having to run check disk on an NTFS file system, or, having bad blocks in your ext file system? If you're building something dependable today, like any good opinionated architect, I'd urge you, stop, take a different approach. So PLC and microcontrollers, I'm going to loosely put them in the same camp. PLC is, so top left here, I've got a bit of a Siemens one here, is a more ruggedized version of a microcontroller. So you'll soon learn I run both a commercial PLC and a micro in my house, plus a Pi. The latter, the Pi, it's not critical. It's the presentation layer. It's the fluff, the human interface layer, that these phones sort of interface with, or Alexa. Everything has a different use case. And I think you understand that in IT. We're talking about containers from, running Azure Kubernetes service through to container instances versus, building your own. There are trade-offs and pros and cons. So a PLC, they're like a cockroach. They are so reliable. They are field serviceable, and they often will contain things like dips or dual inline packages. Do you remember those chips with, legs on them? So manufacturers from Allen Bradley, Rockwell, Siemens, they'll more than likely provide parts for devices from like the 80s. So it's just like if you have a server in a rack for a HP ProLiant G1, you'd probably still be able to get a part for these. And they just work. They talk a lot of sensors. So from, analog, sensors, PWNs, MPN, PNPs, they support them. But, there's trade-offs here, right? And probably the biggest one is cost. Hey, go for it, James. Ask away.
I want to know, how did you go about getting them? Like, do you just buy them on like Alibaba, or is it like I need a supplier relationship to get a Siemens PLC in my house?
Well, I don't have a Siemens. I have an Allen Bradley, but you can just buy them off eBay secondhand, or you can buy them brand new through retailers. So yeah. So look, the PLC I bought has, it has 8 inputs, 8 outputs, and traditional I/O. Not outside, it's got buses and protocols to expand its I/O. But just to give you some, frame of reference, you can go and buy like an 8 relay board for a Pi or a Arduino for probably about $15-20 on eBay. 8 relays cost about $750 for one of these, right? So what's the difference? They interconnects. Firstly, we're talking, they're going over a bus, so it could be something like I2C. It's kind of harks back to the 70s, 80s. Remember, it's about reliability, and they're certified. Remember, these PLCs are being used in warehouses through to hospitals and everything in between. They need to be reliable. Often they are supporting human lives and so on here. So a microcontroller like the Arduino here, I'm going to loosely say they're almost as good as a PLC. They lack certification. They aren't designed for hazardous environments, but they're pretty solid. Bits of kit, you can author your code. It's C, super reliable. It's not ladder logic in the form of a PLC. But, you know, Haas just mentioned before some of the trade-offs in picking your platform. Take this Arduino here. It's got a whopping 32 kilobytes of NVRAM. So you're limited to what you load. How do you load a stack in that can communicate with Azure IoT Hub? You can't, right? Like, you just can't. So there's newer micros like ESP32s, ESP8266, and Realtek offerings that have up to 4 meg of RAM. And we at Microsoft, just a few days ago, we released a C library for Azure to get your telemetry from Arduino, from an Arduino-based microcontroller. And I must stress, things like the door just posters just came here. Just bear with me for one moment. It's going to get a package. Sorry, guys. Someone's got that. Great. All right, keeping it real. I must stress, even though it says, you know, it's Arduino, it's a lot of these newer microcontrollers, ESP8266, ESP32s, etc. They are Arduino compatible compliant. But, you know, that allows you to get your telemetry into Azure really, really easily. So overall, I'm a really big fan of things like Arduinos, but hey, you know, it's in C, and C is not everyone's cup of tea here, right? It's still, you know, somewhat a little bit hard. But I can't live without my Pis either. I've got 3 in action. Neither are what I would say is critical, but they're really important to me. So from left to right, you know, in here, it's my programming Pi. So it speaks to my PLC and it speaks to the Arduino via a USB UART, so serial port. This is how I program my equipment, you know, send them new code to run. And it acts as the glue also between Azure and my house. And I'll get into that, you know, more a little bit later. So the middle one runs Home Assistant. So I went from a Dockerized light version. So I think Windows Server Core to the full fat version. It was just too hard to operationalize. Every time I wanted to add a module in, it was just a pain and the community support wasn't great. And on the far right, I've got a TV tuner, seldom used. But, you know, my kids obviously, you know, all about YouTube and streaming services. So I run something called TV Head End on there. But think of it as a Pi that has an IP accessible tuner. So if I'm overseas with work or traveling and I want to watch some sport, you know, kind of do it that way. All of them have POHATs because I love power over Ethernet and things that are rack mountable. So monolith or microservices. You might think, hang on, are we in the right talk? Did I say that? This is where I want to caveat that things have changed. And when I started out in this caper, or perhaps in the very small sense of IoT, you probably have a monolith. Think about what I just showed you. You've got a PLC or a microcontroller, a Pi. If you just confine to one system, how do you get the I/O accessible everywhere? How do I get James's, not picking on James here, but how do I get his Philips Hue lights accessible to understand what their state is in, you know, my other systems here? So I'm just looking at Luke's comment. Yeah, I don't know if it was another IoT device, but I did buy something today to test out the Arduino. I bought another ESP8266 device, but I digest. But I think the biggest challenge, right, is how do you get everything to talk to each other? And I think that's the biggest challenge we face in IoT, from the factory floor to your house. You know, how do you get communication between disparate systems that don't want to be friends? So this is not the Death Star. This is a depiction of Netflix architectural framework, you know, using an APM tool. This is like, you know, ultimately it's a microservice architecture. And why I'm talking about this is because these protocols, they're kind of like, you know, allowing a polyglot ecosystem. You've got polyglot persistence. You can have multiple different systems talking to each other. And the glue in my house is MQTT. So my house is made up of many discrete systems. So I've got serial, that's RS-232 and 485 from an alarm system and other sensors. I've got DMX for lighting. I've even got some really old X10 appliance modules that I do need to replace, but they just kind of work. I've got TCP/IP. I've got one wire. I've got Philips Hue, James, as well, only the LED strips, and I'll explain why later. I've got TAS motor. If you're not familiar with TAS motor, pop it in. It's a GitHub, it's an open source firmware, kind of like OpenWRT if you're in the networking sort of space. It is amazing. But how do you get these systems to talk to each other and maintain a common understanding of state between the systems? So whilst all my important I/O comes back to the PLC, it poses a real challenge in this decentralized world. More so, it can become costly. As I said, 16 channel of relays, it's probably going to cost me north of $1,000. Whereas for the Arduino Mega, I run an Arduino Mega 2560 with 54 digital I/O pins, including, like 16 relays and a PO hat. I'm probably not out of pocket more than $250. And it came to a crunch point for me where I was running out of I/O, and I'm like, this is crazy. It's costing me a fortune. Do I do things properly, or do I do it half-assed, right? And I'm going to talk about, designing for failure later on. Because when I say doing things properly, it's about building things reliably. If you get a power cycle and you've got your garage door controlled to a relay, you want your door to open, right? You need things to be able to, you need to build fault-tolerant systems. So I went down the path of, I wrote a HTTP interface between a PLC and Arduino. I implemented a HTTP library on the Arduino, and I had the PLC over TCL/TK query the Arduino. Tell me about your state. But, it was a challenge. So MQTT, so it's an Oasis standard messaging protocol, extremely lightweight. It's pub sub, and it's ideal for connecting remote devices with a really small code footprint and minimal network bandwidth, as Has mentioned earlier. Arduino's got 32 kilobytes of RAM, and it fits in, right? So Azure, has services that have an MQTT. I'm not going to say broker because we don't claim we're an MQTT broker, and we're kind of a little bit limited there. But ultimately, I can synchronize what's happening in my house to Azure. I can do bidirectional communication, allowing messages between device and broker and the cloud. It's reliable, so there's QoS, kind of like in network. There's quality of service to ensure messages are delivered, and delivered, can be multiple times. There's QoS levels, and it's really fantastic. So the broker in my house is something called Mqtt. Incredibly popular. It's made by Eclipse. It runs on a Docker container in a rack-mounted NAS. Incredibly lightweight. The Docker container uses a whopping 2 megabytes of RAM. It's like 40 meg in size. And it's really reliable. So, look, my kids I can hear them running about. They're about to go out. But live demos are always interesting. Now, you just saw, you may see things that kind of illuminate here, but every time there's a message that's happening in my house, there'll be a pulse ultimately here. It's probably a little bit hard to see, but I'm doing about 1.4 messages per second. I think they're probably watching TV, so probably, there we go. We just saw humidity update, something. But this is kind of looking at all the MQTT messages that's coming around. So this program has subscribed to messages here. But if we think about devices can be subscribers and they can be publishers. So, I've built my own thermostats here, but let's just take a thermostat here. I can have my visualization layer, which is Home Assistant, subscribe to the state of my heater, but I can also have it published to the topic. And the heater itself can also be a subscriber. So when I say, hey, go to 23 degrees, I've published a message, and the heater is subscribing, it's listening to that topic. So it'll say, hey, I am currently this, and you've asked me to go to this temperature. I better change and, do what I need to do. So it's really, really awesome as a protocol. So this is a real demo of MQTT. This is when I transitioned.
Alexa, turn on roller shutter 3.
Okay.
Alexa, turn on roller shutter 4.
Okay.
Now, because of the logic, given that it's less than 23 degrees, the PLC should overwrite, and the fact it's light outside, this within 1 minute. It's all code.
All right. So this was early on. I had at that stage 4 roller shutters. I think we're up to about 10 now. So I have 4 relays per shutter. Software interlocks as a safety mechanism, and each up and down direction is a separate MQTT topic. There's a lot going on here, right? So obviously they're being exposed as MQTT. Alexa is hooking into that through another bit of software running on a Pi. But, you know, in short, MQTT is the glue that holds everything, you know, happening here. So my shutters, they move up and down based on alarm system state. The house gets armed, they go down. The temperature gets too hot, they go down. Lux levels, so whenever it becomes daytime plus X hours, depending on the day of the week, you know, Monday to Friday versus a weekend, and the month will dictate when they open. Obviously, because sunrise is not a static time that floats every day, and they obviously go down at nighttime. So, you know, a lot of logic there. But look, I'm not trying to do things half-baked, right? So how do you build systems that won't fail? And I think the biggest learning I've got is, just like Haas mentioned, you kind of use industrial automation in a lot of way. I have. So my house is a smattering in what you'd find in a building that you walked into an office place, right? So I run in a range as my alarm system. It's the, you know, Cisco systems of security. I run HID card readers. I have robotics cameras. I use Cisco switching and access points. Don't so much use these card readers these days. Whilst I'd love to just be able to, you know, grab my phone and hold it against them, if I'm being honest, I don't use them. They're kind of a backup, you know, in-laws, etc. They've got fobs. So you can use phones against them, but they're a license unlock. So to hold my phone against it is a couple of $1,000s, and I'd rather not spend where I can just, you know, open up and go open the door. So they're useful, but it probably harks back to yesteryear. So look, one of my learnings is if you take anything away from this session, other than I'm crazy, it's cable and RS-232. You've got wireless, you've got things like infrared. Infrared is incredibly horrible as a mechanism. And look, if something works 99% of the time, it's not really good enough. My family will probably jump up and down. Infrared, as I said, was probably one of the worst experiences I've had in terms of reliability. I tried to use TV remote probably 10-ish years ago and intercept the infrared and then have the PLC do, you know, this and that. But the thing is, light can affect infrared. So look, these days, yes, I am moving more and more to wireless. I'm employing a large amount of Tasmota-based firmware devices, but try and keep things as simple as possible. You know, that whole keep it simple, stupid mantra. So how does my house hang together? So there's a lot going on here, right? So there's about, so James is, you know, zooming in here. There's about 6,000 lines of code. And look, today when I make change, I do a basic, you know, not automated regression test because everything needs to work. So the main systems in my house here is the Home Vision Pro. That's my PLC. It's in charge of overall logic, scheduling, and control. So if any one system calls the shots, it does, but it has its limitations. And when I say limitations, the limitations are more about modern systems. So things that are communicating over HTTP interfaces. I've got this inner range system. It controls my doors, my locks, and motion sensors. So think of it as, you know, Azure Event Hub. So it's spewing out messages that are being consumed by the PLC. There's a few, yes, there is a few AWS offerings here, SNS. I still need to rip a few of them out, but that takes time. But, you know, ultimately there's an Arduino, there's a PLC, there's Mosquito, and there's a whole, you know, just things that, you know, break off here and there. So power over Ethernet, if you're going down this journey, it is awesome. It makes things easy, right? So we're talking things from powering all the access points, the cameras, the Arduinos, every Pi has a power over Ethernet hat on there. It simplifies installation. You know, it's a mechanism for remote power cycling. So for example, when the house gets armed because people have left, why do I need to run 4 access points? Why can't I just have one in the garage in the front of the house? So what happens is, you say either via Alexa or via Home Assistant, the house, because everyone's left. So, a message ultimately will be sent from the PLC into the alarm system. The alarm system acknowledges it, sends a message back, and then the PLC fires off a Python, opens up SSH into the catalyst switch and kills the ports. I've reduced the surface attack area, and I'm, probably saving a few cents. But I do it because I can. So look, key systems. For me, as I mentioned, it's the PLC. All roads lead to Rome, and this is just rock solid. It never breaks unless I do something stupid. It just keeps going. And my model is really old. It's 8-bit. If anyone is writing code here, 8-bit, right? You can't have integers greater than 255. So what do, right? So you use a flag or a toggle and so on, right? So it makes you more resourceful. Now, this was a bit of an older picture here. There's a lot more going on these days, a ton more. So what you don't see here is another bank of 32 relays and a heap more cabling. But, it's 8-bit. There's 32 digital I/O, 8 are analog. There's a lot of dual pole single throw relays. There's buses like I2C and so on. Why I still use it? Primarily because it has an MQTT library. It has brought this device into the 21st century because I can just expose all the I/O as an MQTT topic. The logic is kind of simple, but kind of not. No case statements here, folks, but incredibly powerful. I'm communicating to my audio system here, so it's an NAD system. It doesn't accept ASCII because it's also quite relatively old, harks back to the early 2000s. So you need to send like a start bit, like 1,20, then the bit, and then you got to have the checksum and a parity and stuff like that. So, a bit of challenges. And look, Arduino, on the other hand, is kind of similar, right? It's written in C. Plenty of thriving community around Arduinos, MQTT. So, that's what we're seeing here is the Arduino subscribing to roller shutters, and there's a function there for listening for messages that are coming through MQTT. We've also got Pis, like I said, right? I can't live without these. They're pretty important to me. So look, Pis, they are my programming. They're not critical. So we can see here, in the very background, we've got the PLC output. You've got an Arduino serial monitor, and there's a Python bridge that I've written, and I'll talk about that shortly, which is any message that gets published into Mqtt now gets pushed into Azure as well. We've also got my alarm system. So these are my eyes in my house, right? It's the data for me to act upon. This was around 2012. I bought this in a range model purely because it had an API. And I don't know if I'd go down this path now, but look, if you walk into a building, have a look next time. If you see like a panel or a card reader, odds are it's probably an inner range model. So I didn't know much about it, but I thought, how hard could this be? So I decided to wire it up myself. Ended up bringing someone in to program this for me. This is back then when I had a few Pro Lions. I think that's a G5. So I ended up moving to a G7, but these days, they're nothing more than ornaments. So protocols over devices. So I'm hoping, James, we're still friends here. So look, I want to talk about, I guess I favor openness rather than closed systems. Having Alexa control a light is cute, but how does it scale, right? I've got over 100 lights in my house in various form factors. It would cost a fortune probably to run Philips Hue for every one of these. But more importantly, it comes back to turning my house into that science experiment. What happens if someone turns a light switch off? It's going to break the Hue, right? Because the Hue is, the light switch is going to be that switched active. So I don't know if you just noticed my lights are flashing here. So my wife has just opened the garage door. It's an MQTT topic. it's picked up. Home Assistant, so I've run a Philips Hue light strip behind here, and that lights up when things are flashing, right? So protocols are your best friend, from MQTT, AMQP, Zigbee, Z-Wave, and so on. You've got multiple manufacturers from GE, Siemens, everything. You've got shims that you can apply, like you can run an MQTT library and expose anything on an Arduino as an MQTT topic. Like, the world is your oyster, as they say. I use a lot of appliance modules. I stick these behind walls, and they control the switched active or the load. They're effectively, a relay that you can control, which I can drive via anything. These days I'm flashing here a firmware called Tasmoda onto one of these. I use a lot of Sonoff equipment, but I flash it with a firmware called Tasmoda. If you're not familiar with Tasmoda, just pop it into your favorite search engine. But it makes these somewhat unuseful devices because they're closed to an ecosystem. Like, if you get a Belkin Wemo, or also, you can buy devices at Bunnings these days. This Tasmoda firmware makes them really, really useful because they can now talk MQTT. So you can have a module behind each light switch, and I can control every light in my house with Home Assistant or PLC or Arduino using standard Clipsal switches. So Andrew asks, what happens when a cable breaks? Do I have redundancy or spare cables? Cables, typically, they haven't broken unless there's physical load put upon them. But in theory, I should be able to pull new cables if need be. It's going to be hard in some cases. I'll often, to get a cable to a bottom story, I'll go from my rack, which is in the ground story, all the way up to the top of the roof, and then down, pull tiles off, and then go down the side before drilling holes in a wall, etc. Nothing's impossible. It's just hard work. So we talk about designing for failure. All right, I think we do that in IT in general. And I've learned about this, one night, 2 a.m. in the morning, woke up in a sweat. My heater upstairs, all the zones were turned on. Nothing was responding. Heaters are just, blaring. Couldn't serial into the PLC. At that stage, I had a 40 amp, 12 volt DC power supply, and I had a power outage. But because it was such a large power supply, it had a brownout. So the PLC didn't just turn off, the NVRAM became corrupted. So, how do you solve against that? And then also, I spoke about I use dual relays for every door in this house. So I've got four garage doors. The relays have to interlock in opposite directions, because if you have a power cycle and the relays lose state and they toggle, do you want your doors to open? So it's thinking about designing for failure. So what we've got here is a very sad and expensive power amplifier. It's lost one of its main capacitors. Now, this was caused by me. I'll put my hand up. I had a towel over this and it was left on and it overheated. So now these days, everything that is expensive, I use a Dallas DS1820S temperature sensor. So I've just built this. I've wired it onto to the end of an Ethernet cable. Remember, I said I've got Ethernet running everywhere, and I often use Ethernet for sensor data. That's not necessarily transporting data, in the traditional TCP/IP manner, from sending serial commands to my audio system through to measuring temperature. So this is not Home Assistant, but you can see here I've got the current temperature of this specific power amplifier. And if I can't read the temperature, I'm defensive. The whole area loses power. So if there's no reading, too bad, you can't turn it on, you've lost power to it. Really old snippet of code here, again from the PLC. These are native numbers here. The temp values, I think, are Fahrenheit plus 50, I think. But in short, can't read the temperature, power, whole area gets forced off. Now, the human interface, it's changed. I would say every few years. This is how my family interacts with our house. initially I started writing my own app in classic ASP. So this would have been 2005, 2006 era, HTML5. And then this platform called NetIO came out, which is actually not too bad. You know, it was socket based. It was really good. But, you know, again, it has its limitations. Didn't really have a broad ecosystem. So I would say, as an industry, we've probably settled on something called Home Assistant. So if you're not familiar with Home Assistant, it is in the top 10 contributed Git repositories. So if you are starting out on your home automation journey in 2021, 2022, this is where I would start. Now, why Home Assistant? Other than an absolute thriving community, there is around 4,500 native integrations. So if you have a Samsung TV, as an example, or my irrigation controller is Open Sprinkler, through to a Synology NAS, everything just seems to talk to it. Yeah, it kind of does look at DIY SCADA. So it's incredibly extensible. You know, it's all based on YAML on the back end. There's still a bit of code behind the scenes, but it's incredibly extensible. Again, you know, it reads and communicates MQTT. MQTT is one of those interfaces here. So Alexa, I use it, you know, coming from Amazon, and our house is riddled with these devices, but not that much. So, you know, I'll show you a little bit of a demo, but to me, you know, Alexa is, it's a little bit of a toy, right? So there is an excellent product out there called HA Bridge, Home Automation Bridge. And what it will do, it will allow you to expose almost any device. It runs as a Java applet, it emulates a Philips Hue device. So Alexa thinks, hey, I'm communicating to a Philips Hue device.
Alexa, turn on upstairs heater.
Okay.
Alexa, set upstairs heater to 22.
Okay.
All right. So, you know, it's kind of good, but it's kind of a gimmick. I want to be able to walk into a room, motion sensor pick up and say, hey, no one's in here, the power's off, turn it on. Consequently, when people leave, I also want it to, you know, auto magically turn off. It's just too slow as an interface really to be acceptable. So look, feedback loops, just like, you know, coding, you need mechanisms. I have my Arduino Mega push anything that happens to the PLC, but I also, you know, have them synchronize, you know, a lot of the time. The same goes for my alarm system, door states. I don't want to trust when I've said, turn on the alarm, that, hey, the alarm has turned on. You need to design and build feedback to ensure that your state is always synchronized. So you probably see this was written in VB script here, but old interface. I've just turned the area on, alarm sleep. I think something happens in. I hope so. What's going on? All right, there's a C script. I'm turning the switch ports off here in VB. Back in those days, it's not Python. So the moral of this here, until I got a response back from the alarm system to say, hey, I've armed, I'm not updating my user interface, NetIO at the time, and I'm not sending out a push notification via SNS, Amazon SNS at that stage. So you may be asking, I want to start automating something. How do I start? There's no shortcuts here. You kind of need to understand how things work. I wanted to automate my heating. It didn't just happen. You know, I took my thermostats off the wall and reverse engineered them. I built my own. So, you know, I got an article on that on my blog here, but you need to do the hard yards, unfortunately. I'm all about stealth mode because it needs to look like a normal house. So, Clipsal light switches, I run, Clipsal 30 PBL, so those push button Clipsal lights that have a little illumination on there. This looks like a normal standard heater intake, but it's hidden. There's a Cisco AP and a subwoofer in this case here. All the access points in my house are kind of, neatly hidden away somewhere. There are so many things that make my life easy. From not having switches to turn on fans. We measure the humidity. When the humidity reaches a certain temperature, humidity value, the fans automatically turn on when someone's having a shower, through to access points, etc. But look, for me, I used to commute to and from with Seek. Just a demonstration here of the auto unlock feature of my house. So when we drive up or ride a motorbike, push bike, etc., as long as we've got our phones, our house typically automatically unlocks itself based on quite a few parameters. So hopefully in a moment, when I just start standing here we go, my phone has locked on to our Wi-Fi, and because of a few parameters and some timers which I've manipulated for this demo, my garage door is opening. We have a 4-year-old girl inside giggling away. Now, as our garage door has got to its home position here, based on a magnetic proximity sensor, our lights have automatically turned on. The PLC sent a command to the appliance module. There's our AP that's in our roof. I think it's a 1400 series IOS. When the garage door has got to its home position, the PLC has sent a serial command to the alarm system to automatically lock our garage door. Our internal door between the house and the garage. So as we can see, I can't open it. So if we log into our panel off screen, we can see the doors that this controller is able to manipulate is just only the front and the garage door. And we can see it's red, indicating it's locked. Now I have just a standard Clipsal 2-gang plate here. Now these switches here are all for our lights and being lit up blue, indicating it was on. It's just turned off based on a timer just finished. But if I press a single switch here, it does nothing. But if it's pressed twice within 1 second, based on timer having to iterate and the inputs changing from high to low, it then tells the PLC, tells the alarm system to automatically unlock the door. So let's just try this. Door's going down, we heard a click, and you can look at the panel now that our garage door has unlocked, our internal door has unlocked, and we can enter the house. Simple as that. So there's a lot of other different things, but that's kind of like, a sample of some of the things that just magically happen. So, you arrive home, it'll understand if people are in the house, if no one's in the house, how long people have been away for, who's arrived home, what their preferences are, if they're cooling, heating, etc., and so on. But look, I like the fact, particularly as someone who used to motorcycle to the city every day, that I didn't have to get off, take my gloves, grab a phone, open the garage door, and so on. All right, so I haven't spoken about Azure as yet. I've been rambling on for quite some time. No Azure. All right, so let's talk about it. So look, there's 3 laws of, do I have an opinion on Openhab? I'll get to that in a second. There's 3 laws of IoT, right? So there's a law of physics. And there's a law of physics, there's cost. So sometimes, it's not feasible to push everything into the cloud. And in often cases, there's a bit of, regulatory. But in terms of the law of physics, I don't want to make a call out to Azure to open my door. Losing internet wouldn't bode well if I couldn't turn the microwave on. So what do I use Azure for? So I've been here, 6 months at Microsoft. I've managed to author 4 posts on Microsoft. on the Microsoft tech community, and I'm getting a semi-decent grip on what's available in the capabilities. I think I know a little bit. I wouldn't say I'm the be-all and end-all expert on this space here, but from an IoT point of view, Haas spoke about, moving up the stack. I'm just going to quickly skim over a couple of marketing slides here. But you've got like IoT Central. It's a really low friction offering. It does a lot. It has those fancy dashboards, etc. You've got the IoT Hub, which is, I guess, more choice, more control, but more complexity. Through to digital twins, so FreeRTOS, I really love that. Now, FreeRTOS is really adopted by the community. It's a really common real-time operating system, RTOS. Other cloud provider has one as well. It's really good. It's really reliable, and that's probably the horse I would back personally over something like Azure Sphere. Again, I'm not going to cover it. There's IoT Edge and beyond. But, what is really clear here is it's a very comprehensive state that Microsoft has around IoT. IoT Hub is definitely the basis of our PaaS offerings. Bidirectional communication designed for millions of devices, multi-language, and I really, really, really love the SDKs, and I'll get to that in a bit. Speaks HTTPS, AMQ, PS, MQTT, and I'm going to say kind of, right? Because we're not a traditional MQTT broker. There are limitations. We are not fully MQTT compliant, but you can send telemetry, receive commands, you can device manage, you can do device twins, queries, jobs. It has an enterprise scale and so on. IoT Central, as I mentioned, really simple to get started. It's going to give you a lot of insights. It's really easy. Again, less choice. But if you're new to this space, you're going to spend less time managing your IoT devices when you're using IoT Central than having, to pay developers, people to build stuff on the back end. And finally, there's IoT Edge. And I've had a good play with this actually, right? So, these are for those workloads that aren't able to maintain that physical connection to Azure, but also, you want to do your logic locally. Again, I don't want to have to call Azure to turn a light on. That's, if my internet goes offline, not great, right? IoT Edge potentially could play the part there. Compatible with many popular, I guess, industry platforms, but if you haven't used IoT Edge, think of it as a platform. Ultimately, it runs containers. It's a platform that you bolt functionality onto here. So my journey so far in Azure, and I think as technologists, we know that public cloud brings a paradigm shift in what can be done, the art of the possible, and in the context of this, I'm planning to connect my existing MQTT-based, smart home into Azure, do things like machine learning, through to anomaly detection and everything in between. Think about the bells and whistles that Azure, it graces us as far as capabilities that I could do on-prem. I'm not going to be able to do that, right? How could I tell who has the longest showers? Who wakes up first? What devices are powered on yet there's no activity? Really hard to answer those questions inside my house without using Azure. So I'm really familiar with MQTT, but I'm going to say I'm a little bit new to Azure IoT. So I'm on a bit of a journey at the moment. Now I'm going to pause here and just answer two questions in the chat. So an opinion on Openhab. It's a very viable platform. It would probably be the second, I would say, to Home Assistant, but Home Assistant is it's had that hockey stick growth later, in the last few years here. Definitely viable. Oleg asks, do you have opinions on Homebridge and Node-RED? I'm not familiar with Homebridge. Node-RED is really good. It's a simplified approach brought out by IBM. Pretty popular, and you can flash it to a lot of devices. All right. So my challenge was my house generates around 15,000 messages per day. I wanted to push these. So these things on the very far left here, from Mosquito, and I'll say home assisted, but ultimately Mqtt, because you've got a PLC, you've got an Arduino, you've got Mqtt, and they're all feeding into, sorry, you've got a PLC, you've got home assistant, and home assistant and an Arduino. They're all feeding into Mqtt, the MQTT broker. How do I get those messages? How do I bring them into Azure? So I started off initially, and I'm going to just change screens here. I authored a blog post talking about how do I get Mqtt client tools? Because I will say, you know, when we talk about protocols AMQP and MQTT, that we probably backed the wrong horse at Microsoft with AMQP, because the industry, a lot of devices speak MQTT, but they don't speak AMQP. And Mqtt is probably the de facto standard when it comes to MQTT. So how do I get the client tools to publish a message into Azure? If I've got a light switch, that is MQTT. How do I, you know, I need it to start somewhere. So that was kind of like, you know, what I was trying to build here is trying to get, myself sitting on my desktop. How do I publish a message in? How do I talk to Azure IoT Hub? And at a high level, it's, you know, create an Azure IoT Hub, you pull out the connection strings, you create an IoT device, which is really important here. You need to create an IoT device for every device that's pushing content in. You create a SaaS policy, a TLS certificate, and then you wrap it all together. Sounds simple, right? But Has mentioned before the limitations of low-powered devices. Not all devices speak TLS, right? The default MQTT runs on 1833 typically, but Azure mandates MQTT over TLS. And what's more, it uses a certificate authority that's not, you know, part of any operating system, you know, default keychain. So you need to bring down the PEM file itself, right? It's bloody hard work, right? You need to, you know, deploy the certificate keychain. And the cherry on top, which makes MQTT on Azure kind of really hard, is you need to publish. You can't just say, I'm going to publish a message to /James/James's house /likes/study. You have to go devices, device ID, which you get out of Azure, messages, events. And if you don't publish in that message in that format, your message disappears into a black hole. Azure IoT Hub will accept it, but the message goes nowhere, right? So it's possible. As you can see here, I'm publishing to devices. My device was called Mqtt, messages/events, right? So it's possible. And you can subscribe and you can get stuff back. And then you can validate the message has been received via, you know, Azure CLI using the IoT Hub, right? So it's possible, but it's hard work, right? So how do we make this easier? So I thought about, all right, could I pull out Mqtt and could I replace it with IoT Edge? Could I run IoT Edge on a Pi in the rack, get rid of Mqtt, and make it all happen? And the answer is you can, right? You can do that. So I'll just zoom out a little bit here. Got some pretty cool ASCII art in the logs. I love that. Spent a lot of time in there. Right, so IoT Edge, think of it as a platform. It's a container platform. You ultimately deploy Docker. So you install the container Edge runtime, you install IoT Edge, you configure it, you enable MQTT, which is a module, you publish to it locally, and then it publishes back into Azure. But I will say a few things here, right? Firstly, ARM64 is in public preview. So is Mqtt support. And combining two things that are in public preview didn't bode too well, right? A lot of finding bugs and so on, right? So it is possible. It's just not supported today on a Raspberry Pi. So it will be supported in the future, but just not now. So, it's a matter of, again, you can't just do an apt-get install because Microsoft's repositories aren't by default supported. You install the container engine. You install Iot Edge. I had heaps of problems here, I'll be honest. I spent a lot of time banging my head against the wall. It would often work and often would kind of be a little bit flaky. You create your devices. So not only do you need to create your IoT Edge device, I thought, right, I'd create an IoT Edge device and I'd have my devices published to it. So a light switch, temperature sensor, whatever. But you still need to define those devices also in Azure and make them a child device, which kind of made it a little bit hard. And the other point, hopefully you're all familiar with SAS tokens. They're short-lived. A lot of things use X509 certificates. So again, it's a little bit hard. So what made this a non-starter realistically for me was the fact that the topic structure is still defined like this, right? You still need to define a topic structure. Every IoT child device has to have a topic structure like this. And what that means is ultimately, I've got a light switch behind me that has a module. I'd have to connect and reconfigure obviously I can do that remotely over IP, but I have to go into every device and update it to use Iot Edge. And I'd have to reconfigure everything. So, a lot of hard work. So ultimately where I've settled at the moment is I've built my own bridge. And what inspired me to do this? There was a blog post on AWS where Mqtt natively speaks to AWS IoT. And I'm thinking, why can't we do the same on our end? So Mqtt is an MQTT broker. Now in MQTT, there are topics that you can subscribe to. Now, one of these topics that you can subscribe to is you can have, hashes and wildcards and stars and stuff like that. But if you subscribe to the topic hashtag, anything that gets pushed out, that gets published to Mqtt, it's going to, send to a system that subscribes to just that, to the initial hashtag. So what I ended up building was a Python script ultimately that uses the open source Paho library and the Azure IoT SDK. And it subscribes to any message that gets published to Mqtt and then publishes it into IoT Hub. Really simple to do, pip install Paho MQTT, pip install Azure IoT device.
Does that rewrite the topics?
No. So it uses an SDK call. So it doesn't use MQTT. So I'll bring up actually VS Code, but it's really bloody simple. If I zoom out here, there's 84 lines of code and half of that is. So I'm connecting via MQTT, but how I'm talking to Azure is via an SDK call. So let me just scroll through here. When it starts up, I connect to my MQTT broker and I start listening for messages. Then when I get a message, on message, I decode it and then I run a function to publish to Azure. And all that does is invoke the Azure IoT SDK. Thanks, Haas. All I do is invoke the Azure IoT SDK and I publish it using an SDK call. So really, really, really simple. And I'll show you this as a demo. Look at that Azure CLI here. We're just listening to events. So there are a few messages that had a quas layer higher than 0, but as messages arrive in, they're instantly just picked up because it's constantly subscribing and it's pushing them into Azure IoT Hub. Works really simple, and what it means is I don't need to change any of my device configuration, and the SDKs are just so much easier for me to manipulate than reconfiguring devices. So I've created my bridge, which is grabbing native MQTT and turning that into an SDK call. And look, right, so learnings thus far, you know, you can see a little bit of a gap. Ooh,
now's the time to make what's next count and make RMIT your
YouTube. All right, but you can see here some learnings, right? Just over a typical day, I can tell, let me bring a laser pointer here. You know, I can tell here that my kids have screen time at this, you know, point in time here, right? They're kind of like, they're on their devices, they're mucking around, they're hardly moving. But I can definitely plot the ebbs and flows in my house. And I'm, you know, plan to, you know, push this, you know, into Azure, you know, to extract this and that, you know, part of my learning of our platform. But I've built a mechanism where I can push all of the telemetry into Azure really, really easily without doing anything, realistically. So, you know, I'll just plug this. 3 days ago, Microsoft released a library for Arduino. So if you are a bit of a, you know, a tinkerer like myself, now you can get your devices, you can get your messages into Azure IoT really simply. That said, I kind of see this as a little bit misleading because I think a lot of people will think Arduino, if you're familiar with Arduinos, maybe like an Uno or a Mega, these are the Arduino clones that have taken the market by storm from Realtek, ESP, Esprif, that are Arduino compliant, but they've got like 4 megs of RAM, so they can load in, you know, really large libraries and things like that. But, you know, looks on face value to be rather simple. Now, I'll say Azure and Azure and MQTT, it works, but it's a bit of a rough path to take. Microsoft will be coming to town with a full-on MQTT broker, but today we do not support quas levels. So if you want to send a message and you want to validate it's arrived at the destination, that's quality of service. Yeah, it's quas level 1. We don't support that. So it's kind of like a UDP message. Send it and hope for the best. The X509 certificate chain is also, you know, a little bit tiresome because of the fact that the root certificate authority is not understood by basically any device. So you need to, you know, build that in. But most importantly, it's that fixed topic. So if you've got a brownfield environment, you'd have to reconfigure devices. And if I'm going to have to go through the trouble of reconfiguring my devices, I prefer to use an SDK. But I guess everyone is different. So look, in closing, if there are a bit of words of wisdom here, I do like Wired. I think it's amazing. It's just reliable. There are no batteries to change. It just works. Serial, it's really old, but there's probably a good reason why, you know, the enterprise IT equipment still has a Serial UART on there, because it just works over any medium. I will always favor a microcontroller over a microprocessor. You don't hear of them crashing. You don't hear of them needing their operating system updated and stuff like that. Some protocols are really hard work, like Q8.8. Openness over closed, designed for failure because shit will break. Use feedback loops, run lots of cable where you can. Solid state is good. Azure IoT is incredible. But, you know, is it for greenfield or is it brownfield? So, you know, if you're starting from scratch, I think it's great. Try to bring a typical MQTT offering into Azure, absolutely possible. It's just a little bit of hard work. And then lastly, if you want to automate anything, you probably need to understand how it works. Do some searches, join a forum, ask for help. Don't be afraid to ask for help. And lastly, can we still be friends? So, I try to, these days, since I've joined Microsoft, post every now and then what I'm doing on a blog. So happy to hear from you.